All right, everyone. Thank you for joining for today's session. Let's start today's session. It is very important session for more than two group mean comparison. Today is 17th day for the training. Today is 1st April 2024. Time is 9 p.m. to 9:40 p.m. Myself, Zahid Bashir. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab, Lahore. What we have covered till last session, we have covered single group analysis and two group mean comparison. And today we are going to start more than two group mean comparison. We will cover half of it today and half of the portion we will cover tomorrow. There are some other topics that we will cover in the upcoming days. So today our topic is more than two group mean comparison. So what we will cover under this topic, before doing this, we need to understand what do we mean by more than two group mean comparison and what are the specific detail about this topic. So more than two group mean comparison, also known as multi-group comparison, involves comparing the mean of three or more groups to determine if there are statistically significant differences among them. This type of analysis is commonly used in research and experimental studies to assess variations in outcomes across multiple conditions or populations. There are several statistical methods for conducting multi-group mean comparison, and they can broadly categorize into analysis of variance. When we have more than two groups for comparing their means, we are basically considering the ANOVA, and the other one is non-parametric test procedure. What are the examples of multi-group mean comparison? For example, if we are concerned with medicine and healthcare profession, we may be interested in investigating the impact of three different exercise regimes on weight loss on obese individuals. We would like to determine if there are significant differences in the mean weight loss across three exercise regimes, helping healthcare professionals recommend the most effective approach for weight management. So here, more than two groups are considered here. If we are concerned with educational domains, we may be interested in assessing the influence of three teaching methods. It may be more than three teaching methods, but we are exemplifying here the three teaching methods on students' reading comprehension skills in elementary schools. So use a one-way ANOVA to examine if there are significant differences in mean reading comprehension score among students exposed to different teaching methods, guiding educational practitioner in selecting the most effective instructional approach. If you are relevant to psychology domain, you may be interested in examining the effect of various stress reduction techniques on anxiety levels in different age groups. Conduct a two-way ANOVA considering stress reduction technique and age group as a factor to determine if there are significant mean effect and interaction effect on mean anxiety reduction, aiding psychologists in tailoring intervention for specific age groups. And in the same way, if you are concerned with finance and economics domain, you may be interested in analyzing the impact of three different investment strategies on portfolio returns in various market conditions. You are going to use two-way ANOVA considering investment strategy and market conditions as a factor to assess if there are significant difference in the mean portfolio return, guiding investor in selecting the most suitable strategy based on market condition. Uh, if you are concerned with market research, you may be interested in comparing the effectiveness of three advertising campaigns in promoting a new product in different demographic sectors segments. So you are going to apply a two-way ANOVA with factor of advertising campaign and demographic segments to determine if there are significant differences in mean consumer response, assisting marketers in refining advertising strategies for specific target demographic. And last but not the least, if you are concerned with environmental studies, you may be interested in investigating the effect of three land use management practices on soil erosion in various ecological zones. You may be using a two-way ANOVA considering land use practices and ecological zone as a factor to assess if there are significant differences in mean soil erosion rate, providing insight for sustainable land management practices across different environments. So what are the categories of multi-group mean comparison that we are going to cover under these sections? The first one that we will cover today is normal data with equal variance. If we have more than two groups and we have normal data with equal variance, what we are going to do with in that case we are going to use one-way ANOVA. If we have normal data but equal variance assumption is violated here, then we are going to use Welch ANOVA. And the third one is if the data is not normal, we are going to use Kruskal-Wallis test. And always remember here, the normality means the number of observations should be greater than 30. If the number of observation are greater than 30, it means our data is normal. So in that case, we don't need to check the normality of the data. But if the number of observation are less than 30, then we need to check the normality of the data. And in that case, if the normality is confirmed, either we need to deal with equal variance or not equal variance. But if the normality is not confirmed there, then we need to use Kruskal-Wallis test. So these are the three considerations that we are going to do with multi-group analysis. So let's start today's discussion using the first case. Now, these are the steps that we need to consider. First of all, we need to check the normality of the data. As I have already mentioned, if the number of observation are greater than 30, you don't need to check the normality of the data. But if the number of observation are less than 30, then you need to check the normality of the data using the same procedure that we have previously applied, one sample KS procedure. Uh, on the basis of the normality of the data, we need to decide whether we are going to use one-way ANOVA or Welch ANOVA or Kruskal-Wallis test and so on. Uh, then we need to apply the mean comparison based on appropriate test. So what is the SPSS procedure? We will check the normality using the same procedure that we previously were analyzing. Analyze non-parametric test legacy dialog one sample KS. We need to put our sample data into test variable list and press OK. Then on the basis of that test result, if asymptotic sig value is greater than 5%, it means the data is normal. In that case, we are going to use parametric testing procedure, that is one-way ANOVA. But remember, during that procedure, we need to decide the equality of variance. So if equal variance is assumed, it means if the Levine test shows a value greater than 5%, it means equality of variance is assumed, and then we are going to finalize our results on the basis of one-way ANOVA. But if equality of variance is not assumed, it means Levine test is indicating a value less than 5%. In that case, we are going to use Welch ANOVA. So if the data is not normal, then you are going to use Kruskal-Wallis test for this comparison. So this is the basic consideration that you need to follow for testing this procedure. So this is the case one, but before discussing this case, let me share the data set with both of my participants. The data set is basically the more than two group mean comparison. This is the data set, and here are 7 examples in this data set. So let me share this data set with both of my participants. Let me share the data set. Just wait for a minute so that I can share the data set with both of the participants. Recording. All right, I have shared the data set with both of my participants. So let's open the example one data set. Meanwhile the data set is opened, let me complete this one. This is the case one that we need to discuss, that normal data with equal variance. Uh, Always remember that when your data fulfills the normality assumption as well as equal variance assumption, the test appropriate for two group mean comparison of such data would be one-way ANOVA. So always remember that your data shows normality assumptions as well as equal variance assumptions in order to validate one-way ANOVA results. So one-way ANOVA is used to compare more than two groups on the basis of their averages. So one-way analysis of variance is a statistical technique used to compare means across two or more groups to determine whether there are significant differences among them. It is particularly useful when comparing mean across a single independent variable with three or more level or groups. The objective is to test the null hypothesis that there is no significant difference in the mean of the group. So what are the assumptions? The first assumption is independence for one-way ANOVA. So first assumption is independence. Observation within each group must be independent of each other. It should not be possible for the value of one observation to affect the value of another observation within the same group. The second is normality. The dependent variable should be approximately normally distributed within each group. However, ANOVA is known to be robust to violation of normality, especially when sample size are large. This is the point that I have already discussed, that if your sample size is greater than 30, it means your data is normal. So you don't need to worry about the normality assumption if your data is greater than 30. Then in that case, we will assume that our normality assumption is fulfilled. The next is homogeneity of variance. It means that the variance of the dependent variable should be roughly equal across all groups. This means that there should be equality of variance in your groups or in your groups data. Then random sampling, it is assumed that you have collected this data from random sampling procedure. Then you are going to use the continuous data over here. So let us discuss a lot of examples that where the one-way ANOVA application is applied. You can read these different examples for applying the one-way ANOVA using your recorded session by stopping the screens. So I will go directly to example one, for which I have opened my data. So this is a hypothetical data file that concerns the popularity of a TV channel using a prototype. The marketing team has collected focus group data. One of the question of interest is to see the difference in popularity of TV channel in different age groups. So we are going to see whether there is a significant difference of TV channel popularity between different age groups or not. This is basically our concern here. So first of all, we need to develop hypothesis. There is no statistically significant difference in popularity of the TV channel in different age groups. The second, the alternative hypothesis is there is statistically significant difference in popularity of TV channel in different age groups. So this is how you can prepare your more than two groups hypothesis statistically. H naught, all groups are equal. It means there is no statistically significant difference in popularity of TV channels in different age groups. And H1 is at least one group is significantly different. It means there is statistically significant difference in popularity of TV. So H1 is alternative hypothesis. So first of all, what we need to do, this is the usual procedure that we need to apply, like we have done previously. You go to analyze, you go to non-parametric test, you go to legacy dialog box, and you go to one sample KS. Then you need to put your continuous variable into test variable box, and then you find the asymptotic sig value greater than 5%. It means your data is normal. Then you need to interpret like this: since the level of significance asymptotic sig2 to tail is equal to 0.092, which is greater than 0.05, therefore the normality assumption is fulfilled. The second thing, decision about test, as the data is normal, therefore we are going to consider the one-way ANOVA for hypothesis testing. Additionally, we need to check for equality of variance. So how can you do that? You go to compare means, you go to one-way ANOVA, and you applied this procedure. You need to put your continuous variable into dependent variable list, and you need to put your categorical variable into factor list, and then you need to click on option button, and you need to check homogeneity variance of variance test, and then you click OK, and you will find like this. So before discussing it further, let us start from our data. This is the example one data as I have shared with you. More than two groups mean comparison. I have discussed with you that you need to open example one data set. So what we need to do, we go to our data set. If you see here, there are two types of data. The first data is basically the score data. The second is age group data. If you see, the age group data is basically categorical. There are different age groups. So this is categorical data. There are more than two groups. There are more than two age groups here, and we need to see whether the score is different between different age groups for popularity of TV. So this is TV popularity score. And if you see the number of observations, there are approximately 68 observations. So according to the basic assumption of normality, according to the assumptions that if your sample size is greater than 30, it means your data is normal. So we don't need to check the normality here. We can assume that data is normal because number of observation are 30. So you can write here as the number of observation in this data is, how much was the number of observation? It were the number of observation were 68, is 68, which is greater than 30. Therefore, according to central limit theorem, the data is considered normal. All right, approximately normal. The data is considered approximately normal. So we don't need to check the normality. If you check the normality and if it becomes not normal, always remember that you need to consider this assumption. If your number of observation are greater than 30, it means your data is normal. Although it becomes not normal in the estimation procedure, but you will consider this assumption as a normal because the number of observation are greater than 30. Now, what we need to do, we go to uh, the next procedure. And what is the next procedure? The next procedure is to go to analyze, to go to compare means, and here you will find one-way ANOVA. You just need to click on it and you need to put your continuous variable into dependent list and your categorical variable that means the variable with a multiple groups here. You need to put it into the factor variable and then you need to go to options, and from here you need to check the homogeneity of variance test. Then you need to click continue, then you need to click OK, and you will find a lot of results here. So what we need to do here, the next thing you need to understand from this slide, you will find a number of tables here. Like you will find here the assessment score, you will find their mean, you will find the Levine test, and you will find their significance value, and you will find the ANOVA, and you will find the sig value of that ANOVA. So how can we finalize what we need to do? First of all, you need to see the sig value of ANOVA. As this value is less than 5%, it means there is a significance difference between groups, but we cannot confirm the significance difference between each group here. So there are a lot of groups, 18 to 24, 25 to 31, 32 to 38, and so on. There are 1, 2, 3, 4, 5, 6. There are 6 groups here. We cannot confirm that there is a significance difference between each one of these groups. Overall we can consider that there is a significance difference, but between each individual groups we cannot confirm that there is a significance difference here. The second thing that you need to see is the test of homogeneity of variance. If you see this value is greater than 5%. So when sig value of Levine test is greater than 5%, it means equal variance is assumed here. We further need post hoc analysis. So we need to go for post hoc analysis for individual differences. Overall, the difference is significant here. It means H naught is rejected, and we are going to interpret this value as if there is a significance difference between groups on overall. So what we need to do, we go again, compare means, one-way ANOVA. We go to post hoc option here. This is the post hoc option, and we need to consider LST and Tucky option here. And then we need to see a group-wise differences. So we go here again. We go here, analyze, one-way ANOVA, options. Previously, I did not check this option, but this option was also required previously. If you see, this is basically the mean of each group, but now we need to go to post hoc. So we go to compare means, one-way ANOVA, and we need to click on post hoc, and we need to check for LST and Tucky. These are the two options which are required when equality of variance is assumed in your analysis. So you need to click on continue, you need to click on OK, and this is basically the post hoc analysis. You need to find out the mean difference values with steric sign. If you see here, this is the value with steric sign. It indicates that there is a significant difference between the age category of 53 to 59 years and 32 to 38 years. So in the age category, in the reference age category of 32 to 38 years, there is a significant difference of 53 to 59-year age category with 38 to 32 to 38 years. Again, you need to verify some other age groups with steric signs. So if you see here, 46 to 52 years age category, this is significantly different from 39 to 45, and 53 to 59 with 39 to 45, they are both significantly different. In the same way, 39 to 45, this is also significantly different from 46 to 55. So you can verify there are a lot of age categories, and in the LSD2 there are a lot of age categories here. So what we have concluded here, that you need to identify those age categories which have steric signs, and you need to compare those with their reference age category. So after doing this, you need to consider here the interpretation. First of all, you need to provide here the overall interpretation, and then you need to provide the interpretation of reference category with a specific age category. So for example, I need to put here the overall analysis. The first of all, the ANOVA value, that is significantly, that is less than 5%. So I need to write here as the SIG value as per ANOVA table is less than 0.05. Therefore, H naught is rejected. We conclude that there is a significant difference between there is a we conclude that if we see the hypothesis structure here, at least one age group is significantly different. So H naught is rejected here, and we conclude that at least one age group is significantly different from other age groups in terms of popularity of TV shows. Now, this is the interpretation on the basis of overall ANOVA table. This is the interpretation of basically this table. Now, I am going to interpret this table, that is test of homogeneity of variance. The SIG value is greater than 5%. So furthermore, as the SIG value SIG value of SIG value of what was the specific name of this test? Levin test. Levin test. Furthermore, as the SIG value of level that is greater than 0.05. Therefore, equality of variance is assumed. All right. Now this is the interpretation of your both of these tables. Now for individual differences, we need to go for post hoc analysis. So what does the post hoc analysis indicated? There are a lot of tables here. So I am just going to interpret some of them. So I will write here for post hoc analysis in order to find out, all right, in order to find out the the differences, the significant differences, the significant differences of each individual group or popularity of the post of analysis was performed using LST and the key for equality of variance, which revealed the following observations. Now, what you need to do, you need to provide here one by one your observation. For example, if I would like to open here my observation using Tucky HSD, I need to write here, I need to write here my observation for Tucky HSD. So I need to write here one by one. For example, in the first group, there was no significance. Second, third. In the third group, 32 to 38 years, there is a significance difference between 53 to 59 years age category and 32 to 38 years. So there is a significant difference between we need to find out what was the reference group 32 to 38, 32 to 38 years age category with term 53 to 59, because this is the significance difference. 53 to 59, 53 to 59. You need to provide here their value. Their value is 7.255. 7 mean difference is 7.255. And what is the other thing? The other thing is the sig value, that is 0.05. C is equal to 0.05. In the same way, you need to interpret the other groups too. Like this is the one example. You need to interpret the others too. So only discuss those which are significantly different from their reference category. So this is all about today's discussion. You need to consider example 2 and example 3 in the same line. Do not consider example 4 because it is related with case number 2. So consider example 2 and 3. So do you have any question, Miss Hina and Miss Rabia, for today's discussion? Please let me know.